consultant at Kroll. I've been doing different sorts of AppSec-related things for the last 15 years. Been digging away at those consulting mines. And a lot of the stuff that I'm going to talk about in this presentation kind of started off as things that we talked to our clients about. They were kind of exploring and using some of this technology, and then I kind of continued looking at it and found some pretty interesting stuff. In terms of like AI and LLM stuff, I personally have done quite a lot of different AI and prompt and LLM assessments over the last year. I'm not exactly an AI advocate. I'm not here to tell you that it's going to change your life or the world or anything. I'm just here for the proverbial zipline. In terms of what we're going to talk about today, so I'm going to start off by just giving a bit of an introduction to what models are, how they work, how they function, just to kind of make sure that we're all on the same page in terms of how you use them and how they work. Then I'll talk a bit about PyTorch models and the file formats they come in, how that can be abused for code execution, and some other file formats that models can come in. Then we'll talk a bit about what inference servers are, how they work, and then we'll specifically dive into security vulnerabilities within TorchServe, Triton, and TensorFlow. So starting off, just a bit of an introduction to machine learning, kind of AI models. And the first question you might have is, what is a model? And a model, you've probably heard that term tossed around a lot over the last couple of years. And in general, a model is basically a program that accepts some sort of input, and then it returns a prediction to you based off of the input that you've passed in and the data that it's been trained on. Models are typically created and kind of made using deep learning libraries, two examples of which are PyTorch and TensorFlow. And these libraries have functions that allow you to kind of create them, train a model, export them out to a disk, and then use them for inference. When I talk about training, again, you've probably heard about training in the context of models. And what that basically means is that you're showing the model some sort of data that's been classified or defined in some sort of way that the model understands, and then it's able to use that model later to provide a prediction back to you when you use it. Once a model's been trained and you send an input to it, you send some new data that it's never seen before, and it returns a prediction to you, the act of doing that is called inference. And you might have heard that term tossed around when you're talking with AI models or you're kind of interacting with them at all. And that's basically the act of inferring some prediction based off of the data that you've passed in and the data that's been trained on. It's also the same inference that is in Inference Server. So an Inference Server is a server that allows you to perform inference on a model. In terms of how the model actually obtains that prediction, how it's using all this data and stuff together, that's actually quite complicated. That's kind of where like the deep math and kind of understanding of models goes in. And as a security person, do you really need to understand all of that stuff? And I would say that kind of broadly speaking, no. There are some things that I think are pretty important for you to understand. And for me, the kind of one thing that really kind of shattered the glass for me in terms of better understanding what models are and how they work is kind of coming to terms with the fact that at the end of the day, a model is a file. It's a file that exists on the file system. It can be used and interacted with. It can be shared, just like any other kind of binary file. So once a model's been trained, you can export it or save it to disk by using something like torch.save, which is a library, PyTorch's library that will write it out to a disk. And then when you want to use that library, you would use torch.load to load the library into memory and make it available for inference. From a security point of view, conceptually running a binary is very similar to running a model is very similar to running a binary file. It's basically some opaque binary data that's on disk, and you're loading it into memory and evaluating against it. And as a security person, you might have a lot of questions or concerns that come up out of that immediately, because it is a bit of a dangerous act. And models, in general, are a bit of a security headache. Models kind of inherently come in some dangerous file formats that the file formats themselves are quite risky to use and move around. Models have supporting files that come along with the actual model weights, so things like handler files or tokenizer files that can be completely custom code. And so if you're dealing with those and you're using that type of files, you need to be aware of kind of what's happening in them and have security controls. Models are really easy to share. There's large online ecosystems where people are sharing models with each other. You can very easily download them and use them in a few lines of code, which I'll talk about in a bit. And the one thing I kind of want to get to is the point at which you are invoking or you're loading a model in to get ready to use is a very important security event. You might, as an organization, have rules and stuff in place for things like third-party libraries, imports. You might have all sorts of automation for that kind of stuff, but you might not have any for a model that's being downloaded off of like an ecosystem like Hugging Face or something like that. So how do you use a model? And I'm going to walk through kind of an end-to-end example of just downloading and using a model off of Hugging Face. You might be surprised at how easy this is. You don't necessarily need a lot of background or kind of skill set to understand it. Sorry. The first thing I'm going to talk about is an application called Hugging Face. If you've never used this before, Hugging Face is basically like a GitHub for different types of models. There's many different types of models that you can download and use. They're all kind of open source, different licenses, of course. But you can just see here in the screenshot, there's almost 1 million models that are just available and can be used by anybody. There are quite a few different types of models on Hugging Face. There's text classification, image classification, text generation, so things like LLMs, where you're sending it some prompt and you're getting text generated for you. You can see here there's a bunch of other ones like text to image, video to image, whatever function you kind of want. You can probably find a model on Hugging Face that supports that. Hugging Face also lets you sort by backend, so you can find models that were made for PyTorch or TensorFlow or whatever other model format you're looking for. The other really important thing from Hugging Face is they publish a library called Transformers. If you've done any sort of, if you looked into any sort of kind of modern AI application, especially one that's using open source models, it's probably using the Transformers library. It's a Python library that has a bunch of kind of magic auto functions that in just a couple of lines of code, you can kind of abstract away the whole process of loading and interacting with the model and get really easy interaction with any given model that you're loading. So it's very common and really cool. One thing I do want to kind of specifically point out is that even the Transformers library, when it is loading a model at the back, what it's actually doing is using the library to load the model. So for example, if you load a PyTorch model via Hugging Face and Transformers, it's still calling torch.load on a file that exists on your file system. So to kind of just walk through an example, this is a random model that I found. I find that this is quite useful for people to kind of understand because this is a very simple model. This is a model that is based off of the Roberta model framework. And the purpose of this model is basically it is a text classification model that accepts some sort of text, some sentence, and it will return to you if it thinks this text is spam or it thinks it's safe or not spam. So that's the kind of the only function of this model. And the way that it works is it accepts a tokenized string, which is the text that you're sending it in. And I won't talk too much about tokenization in this presentation because it's kind of its whole other thing. But on a very high level, when you interact with the model and when the model responds to you, it's not really using strings. You're not sending it like a sentence to evaluate. You're sending it what's called a tensor, which is just a series of numbers in a different arrays, basically. And so when you send input to a model, it needs to be tokenized in order for the model to understand it, and then it will return to you as a token. The output of this specific model will return a 2-value array or a tensor, and it basically just 2 numbers it's returning, and it's returning how likely it thinks the input that you sent in is safe or not spam, and how likely it thinks the input is spam. And that's kind of just the whole function of this model. And the screenshot on the right here, this is just on Hugging Face. If you just browse to this model, you can see a bunch of information about it, including the actual files of the model, and you can just download them like you would on GitHub or anything like that. The 2 models that I have highlighted here, the 2 files, they're the same model. You can see they're roughly the same file size. They're the same model, but they're in 2 different file formats. One of them is called safe tensors, which is a file format I'll talk about later, and the other one is pytorch_model.bin. This is the PyTorch model, so this is the default export of the model from PyTorch. Sorry. And this is how you use the model. And this might be a bit intimidating, so we'll kind of go through it a bit slowly. Maybe the most complicated slide in the presentation. Sorry. So the top here is just a folder in Linux. I have 2 files in that folder. The first one is a config.json, which is something that Transformers uses. And then I have the pytorch_model.bin, which I just downloaded from Hugging Face. This is the PyTorch version of this model. In the middle section here, I have some Python code, which is actually using the Transformers library to invoke this model. There's a bunch of stuff going on. The first line is just a bunch of imports. It's not super interesting. This line is important. This is the actual point at which the model is loaded into memory. This is auto model for sequence classification. This is a function that's provided by Transformers. This is kind of a magic function. It just automatically loads the model. Under the hood, this is calling torch.load on the file that is in the folder, the pytorch_model.bin file. And so this is loading it into memory and making it available for inference. This next section is just the tokenization part that I talked about. Again, you don't have to understand it too much. Basically here, I'm sending in the sentence to this model. Your card has been hacked. go to evil.com. And then I'm using an auto tokenizer, again, just an easy function from Hugging Face to get it into the right format that the model understands. And I'm basically just saving it into a variable. And then I'm sending that variable to the model for inference. So this is kind of, if you were interacting with a model online, you're just sending it in and you're getting an output that comes back. And the output is this. And if you look at the bottom, there's a bunch of stuff here. It looks pretty confusing, but specifically the outputs that we care about are these two values that are in a tensor here. And you might look at it and you might say, oh, this doesn't make any sense, because it didn't make any sense to me initially either. But this is the same two-value output tensor that I talked about on the previous slide. So if you remember, that value was how likely it thinks this input is safe, and then how likely it thinks this input is spam. And you can see here that the second number is significantly higher, where the other one's a very, very low number. And so you can infer from this output that the model thinks that the input that we passed in, which was your card has been hacked, is spam. So this is basically the model functioning in the way that it's supposed to. Now, of course, that's very hard to parse. You would want to probably treat that output in some way. You would softmax it, so you get those two numbers between 0 and 1, and then compare which one's higher. You can label it, all of that kind of stuff. But this kind of show you, like, just with a couple lines of code, you can download a model from Hugging Face, send it an input, and read the response. So with that all being said, PyTorch pickles. So the file format that we downloaded from Hugging Face was a PyTorch model. And by default, PyTorch exports its models in a Python pickle format. If you aren't familiar with what a Python pickle is, basically a pickle is just a set of serialized Python instructions. And the Python interpreter, when it reads a pickle, will just basically perform those instructions as it sees them. Pickles are inherently dangerous. If you go to the pickle module on Python in their docs, at the very top, there's this big red warning that says, pickle module is not secure, only unpickle data that you trust. And if you saw from the previous slide, I just unpickled a file that I downloaded from Hugging Face. This is just kind of how it is with PyTorch. This is their default model format. And by default, these models can contain malicious code, which we'll talk about in a few seconds. What this means practically is that in any engagement or any situation, if you control the input that's passed into torch.load, so for example, if you're the one that's uploading a model that's being loaded in via torch.load, it will lead to code execution, and you can pretty trivially abuse that. There is a new parameter that TorchServe or PyTorch is implementing called waits only. If this is set, it will send it down a new code path, which is a restrictive unpickler, which is theoretically safe. This feature exists now, but it's not enabled by default, and it's still in beta. So right now, basically, if you see torch.load and you can pass in input, you can get code execution. So what does that look like? Here's a pretty direct example. At the top here, I have some Python code. I'm just importing the pickle library. I'm making a new class, and the class is just os.system, and then I'm running the command cat @cpassword. Then I'm using pickle.dumps to dump this payload into a file. So there's now just a file on disk called payload2.pickle. So this is just a pickle that has, when run, will execute this command. And then at the bottom here, I'm doing import torch, which is loading the PyTorch library, and then doing torch.load, and I'm passing it in .payload2.pickle, so the payload I just made. And you can see it pretty much immediately just executes the malicious command I put in. If you've done any sort of looking into machine learning models or anything like this, this isn't particularly new. This is literally just how it works. This is like risk number one when it comes to PyTorch models. They're pickles. They can contain malicious code, and they'll execute when they're run. Sorry. So in this specific case, in that previous example, the entire payload was just my command. It was just a bit of malicious code that's run. If you were on an engagement and you were trying to get like a shell back or something, you would just do something like that. If, on the other hand, you wanted to take an existing model and inject some code into it, you could also do that. So here what I've done is I've taken the PyTorch model that I downloaded from Hugging Face, and I've just unzipped it. Sorry about that. So I've just unzipped that model file. Inside of it, there's a bunch of other files and a bunch of other .pkl files. And what I'm using is a tool called ficking. Ficking is by Trail of Bits. It basically lets you do a lot of cool stuff with pickles, lets you inspect them, it lets you inject code specifically into them, which is what I'm doing here. And I'm basically just injecting the command print injected code into one of the pickle files within this model. Then I'm just repackaging that pickle to back up. And so now I have a new model called newModel.bin. And if I load that into PyTorch at the bottom, so I'm just doing torch.load, I'm passing in the newModel.bin. The map location thing is just telling PyTorch to load it on my CPU because my laptop doesn't have a GPU. But you can see here that the code that I injected runs when I load the model, and then it will continue to load the rest of the model in and kind of continue as use. So if you were using this in like a malicious way where you were injecting this as part of a model, the model will continue to function as it's supposed to for the rest of its operation. It will just have the malicious code you injected in addition. So that's PyTorch models by default use that format. I'll talk a bit about a few other types of models. The first type I'll talk about is called TorchScript. TorchScript is a different type of PyTorch model. The way they describe it is that any TorchScript code can run on Python, but not any Python code can run on TorchScript. This is because TorchScript has a limited amount of PyTorch features and a limited amount of Python features. So if you ever see code that's loading in a model with torch.jit.load, it's using a TorchScript model. And if you actually unpack this file and you look at it, you'll see a lot of files that look like pickles. There'll be .pkl. If you look at them, they look like pickles, but they're not exactly Python-like. And so as you can see here in the bottom right, if I use that exact same payload I had before, but I load it in with torch.jit.load, the error is that it can't find a runtime called builtins.eval. That's because that's a Python function or built-in that doesn't exist in TorchScript. So you cannot as easily exploit this. You can't exploit it in the way that you would by just injecting commands because the amount of functionality within TorchScript is limited. It's mostly math-related functions. So if you can do something there, you might be able to do it. I haven't had much success, and I don't think there's that much research into TorchScript specifically. The next model type I want to talk about is called TensorFlow. TensorFlow is made by Google. It has a completely different type of model format. They aren't pickles. They're kind of in a few different things. TensorFlow models have at least two different types of model formats that are supported. One of them is called HDF5, and the other one's called Save model. Both of these can be abused in different ways for code execution. HDF5 models can contain a function called tf.keras.lambda where you can just put in code, and then when you build and load the model, that code gets executed. Save model also has some features that let you read and write from the file system. I personally haven't done too much work with this. If you're interested, there's a lot of really great research by Tom Bonner at Hidden Layer. You can kind of go there and check it out. But if this is a format you use, you can definitely find some cool stuff there. The last file format I'll talk about before we get into inference servers is safe tensors. So if you remember from Hugging Face, the model formats that were there had a safe tensor model format. This is the model format that Hugging Face puts out. It's very limited in terms of what it can do, and that makes it generally pretty secure. It's been externally audited. If you are using models and you're sharing them and you're using them, if you can choose the format that you're using, you should choose safe tensors because these are the ones that have no known issues that have been exploited. Yeah. So, inference servers. Now we can kind of get to the main thing of the talk. So what is an inference server? An inference server is basically a front-end interface that exposes a set of models for use. So typically you would have a front-end API interface, so either over RESTful APIs or gRPC, which accept input, and then these inputs are sent directly to a model, and then the model invokes it using that input, and then it sends it back to you. On a very high level, they basically just expose the APIs for use for inference. If you've ever used any of ChatGPT's OpenAI APIs, like their chat completions API, this is basically an inference server. You're sending in some data via a post request. It's sending it somewhere into a model, and then you're getting the response from the model out. This is just you hosting it yourself somewhere within your own environment. You're launching and hosting a model and exposing the APIs. Inference servers also tend to expose a set of model management APIs to let you load new models, spin them down, do other sorts of management operations, and these are the APIs that typically can be abused for code execution in a few different ways. You might be wondering why you would use an inference server locally within your own environment, and there's a lot of reasons. One of them is that cloud-based AI providers are quite expensive. You're paying for tokens, you're paying every time you make an inference request, And as new models get released and more models are open sourced, there is already quite a few LLM-like models on Hugging Face that you can download and use. The next Facebook Llama model is going to be open source. So at some point, there is a point where the value proposition for just hosting your own models gets better, and so you can just run it within your own environment without having to worry about like data residency or anything like that. You might want to use an inference server rather than just hosting a model on every single host, because these models can be quite large. The Roberta Spam model I showed was about 500 megabytes, but LLM models can be 50, 60 gigabytes, even larger. So you don't want to necessarily have that running on every single application host within your environment. You probably want a centralized place where all of your applications and infrastructure can reach out and talk to the same model for the same purpose. Okay, so TorchServe. TorchServe is the model hosting component of PyTorch. So this is like part of the repo. It's the thing they use. It's maintained by a combination of AWS and Meta. PyTorch is pretty, I think, maintained by Meta, but TorchServe specifically seems to also involve AWS quite a bit. It has a lot of features, like it supports LLMs. You can do a lot of, you can host quite large models on TorchServe. And it's also a component in a bunch of popular services. So this is just from the README file. You can see that it's a component in AWS SageMaker. It's used as part of Vertex AI, Kubeflow, MLflow. So these features are using TorchServe under the hood to expose their models for use and stuff like this. TorchServe also uses a model archive format called MAR. If any of you have ever exploited like Tomcat vulnerabilities with WAR files and such, a lot of very similar things and also a very similar name. So yeah. In terms of how you actually use TorchServe, so I'll just walk through an example here. The first command here is just downloading a model. So I'm downloading a model called SqueezeNet. SqueezeNet's a pretty old model. It's the one I use because it's the one they use in their examples, and it's pretty simple to understand. It's an image classification model, which I'll talk a bit about on the next slide. But basically, I'm just downloading the model weights. So that file at the top is a PyTorch model. It's a pickle. And then the next command here, this command is creating a model archive file. So this is an MAR file. This is what's used to deploy something new to TorchServe. And there's a bunch of commands here, parameters here. The model name and version, this is just self-descripting the model, the name of the resource. Then model file parameter, this points to a Python file, which is executed anytime there's inference. So this is when you send a post request to the API with some data to be inferred on, this is the Python file that gets executed. And this is typically used for things like handling requests. So if you need to tokenize input, if you need to convert images or something, this is kind of like the starting point of the request. The serialized file is the PyTorch model. So in here, I'm just passing in the SqueezeNet model, the .pth file. This would be the same if I was passing in the PyTorch_model.bin from Roberta Spam. This is like the weights, basically. The handler is just the function that gets executed from the model file. So that can be whatever. And then once you have this MAR file, all you do is you make a model store folder, you move the MAR file into the model store, and then you launch TorchServe. And when you launch TorchServe, it'll launch up a bunch of APIs that you can then use for inference, and you can use the APIs. And so at the bottom here, I have a curl request. This curl request is sent to the predictions API. I'm calling the model that I just loaded, SqueezeNet, and I'm sending in a photo of a cat. And SqueezeNet is basically a model that takes an image and it compares it to 1,000 classes of images that it's been trained on, and it will return to you what it most likely thinks that image is. So that's the point of this model. So here I sent in a photo of a cat, and these are the 5 categories that SqueezeNet thinks the photo is closest to. So it thinks it's most likely a tabby. That part of it is not super important. It's just like this is using the model that we downloaded through this API that we just launched through TorchServe. So security concerns. What are some of the security concerns that come out of this stuff? The first thing I want to talk about is service exposure. So when I launch TorchServe, when I just run the command TorchServe start, it launches 5 different API services, which is quite a bit. It doesn't really give you much indication that it's doing that. The first service it launches is on port 8080. This is the Inference Server. So this is the predictions API I was calling in on the last slide. This is what's used to actually talk to the model, send it some data, get data back from use of the model. On port 8081, there is a management server. So this is the server that's used to perform kind of admin actions like loading, unloading models, things like that. There's 2 gRPC interfaces that both are the same as the previous 2 APIs, except they're over gRPC instead of RESTful API calls. And if you don't know what gRPC is, it's basically a different way to send requests. Finally, there's a metric server that's used for metrics and stuff like this. Earlier versions of TorchServe, so like I think near the start of the year or last year, all of these interfaces were bound to all interfaces, so 0000, which meant that you could broadly access them. That was fixed in an earlier release. That's also a very common design pattern, as I'll talk about. And one thing to think about is that if you're using this within your organization or anybody's using this, you do need to expose these APIs to some degree in order for some client or some user to be able to perform inference or use these APIs. The fact that there's so many different types of APIs and different endpoints can lead to configuration issues and kind of confusion. One of the such cases is the first kind of bug that we reported to TorchServe. And I will fully admit, this is a bit of a silly thing, but basically the documentation for TorchServe stated that by default, the gRPC interfaces would be bound to localhost, but they weren't. So if you launched it, the two gRPC ports, which let you perform inference or interact with the model management APIs, were not bound to localhost by default. Yeah, it's a bit of a silly thing. When I first saw it, I was like, whatever, it's just a documentation discrepancy. However, once I came to know what these APIs can do, it's a little bit more dangerous than that. And that's mainly because there's no authentication on any of these APIs. Prior to the latest version of TorchServe, TorchServe implemented no default authentication. So once you started it, you can call any of the APIs as long as you can talk to that port, perform inference, load models, do whatever you want, without needing to provide any sort of authentication token. TorchServe supported an extension or a plugin that let you do token-based auth, but it wasn't enabled by default, and probably very few people were using it. And this blob here at the bottom is basically just like what was in that documentation earlier, which is, hey, we don't support authentication natively. It's more or less, it's up to you to figure out to not misconfigure this. To be fair to TorchServe, when we did disclose this and some other issues to them, they did fix them, and they also made a lot of security improvements. Unlike the other inference servers I'll talk about, now they do enforce authentication by default, and they also removed the most dangerous of the API calls, which you could use for code execution. So that's good, and the team at AWS was super great to work with. They made a lot of changes really quickly. But this lack of authentication is not unique to TorchServe in any way. Two other inference servers, TensorFlow, which is by Google, and Triton Inference Server, which is by NVIDIA, both do the same thing. They both bind to 0000, so when you launch them, they're bound to all interfaces. It's up to you to restrict that access, and they don't have any authentication by default, which means that if you can talk to those ports, you can interact with the models, and you can load and unload models. You might be wondering why, right? Like this seems like a bit of a legacy thing. This is what people were doing like 10 years ago. Why are they launching new services that function like this today? And there's two main reasons I've seen in the documentation. The first one is that there's concerns from developers around performance, in that needing to evaluate a token as part of authentication causes a performance degradation that's unacceptable. In the context of a model, it's a little bit understandable, but to be honest, I think it's a bit much. I think they probably should be able to check off. And then the other one is that, you should be launching this within a container. This should be like an internal service. You shouldn't be exposing it more broadly. But that puts a lot of emphasis on the people who are deploying the software or being asked to evaluate the security of the software to know intrinsically how dangerous some of these APIs are, because otherwise you're going to make a decision that can be bad. And the main thing that you can do with these is get code execution. And there's a few different ways that this can happen. So I'll start off by talking about TorchServe. So TorchServe in the management APIs exposes an API called register model. Conceptually, this lets you push a new model to this inference server. This API accepts a URL parameter. The URL parameter can point to a file on disk, like a local file path, or an arbitrary URL on the internet. In both cases, it'll go fetch the file that's at the location and dump it into the model store. The file that it gets needs to be an MAR file, so the same type of model archive we created earlier. And this can be pretty trivially abused for code execution. So how do you do that? There's two different ways. The first one is the model file parameter. So when you're building the archive, you pass in a model file. This is just a Python file. You can put in anything you want in this model archive and this model file. And when the service launches and you perform inference, this code will be executed. It's important to note that when this happens, when you load the model, that's not when the code execution will happen. The code execution will happen when you are performing inference, because when you send the request to do some sort of prediction, the that's when the model is using and launching this Python file. So this is how that looks. I've just updated the model.py file. This is just the one that's in their example. And I've just added a import subprocess.run cat at cpassword. So it'll just cat the file at cpassword. Then I use this file when I generate a new MAR file. So I'm generating a new model.py file and a new MAR file with pointing to the malicious model.py file. And then at the bottom, I'm sending a post request to the register model API. And so I'm doing basically saying URL equals attacker.com/injected2.mar. So I'm saying deploy this MAR file, and I'm saying deploy with an initial worker of 1. The server will respond saying model has been registered with 1 initial worker. The code execution doesn't happen at this point. It happens when you perform inference. So if I then try to send a photo of a cat to this model over the predictions API, then you'll see in the service log that the code that I injected into the model is run, because it's basically just running the model.py file to handle my request. So this is one way of doing code execution. The other way, you might have already guessed, is this serialized file. So this is the PyTorch model that I talked about earlier. This can be a Python pickle, and as such, you can inject malicious code in via a pickle that gets loaded when the model is loaded. Important difference with this one is that the code execution happens when you make the post request immediately, because that's the point at which the model is being loaded, and that's when the code execution is happening. So how that looks, again, I'm just downloading the same squeezenet file, I'm unzipping it, and I'm using ficking to add a print statement that just says injected code. I'm rezipping that file up, and then I'm using Torch Model Archiver to generate a new MAR file. And then I'm just, again, sending a curl request to the register models API. And as soon as you send this post request, that's when the code will execute, because it's happening when the model is loaded, not when we're performing inference. So these are 2 different ways of getting code execution. It's in the same API call, but they're in 2 separate locations. And for the most part, the issue here is that this is an API that lets you deploy code. And if you can access this API, you can deploy code and get code execution. So, sorry, okay. TorchServe does give you some controls around limiting who can do what and what you can do with this API. One of them is that you can set an allowed URLs parameter. This is basically an allow list that says only load models from this website, or only load models from like this location on disk. And this is one of the APIs that one of the controls that we found a bypass for. It's kind of a funny thing. Basically, if you have an allowed URLs parameter that limits access to a specific folder, and you send in a request that contains a path traversal payload, so like .. / .. .. / .. / the service would respond with an error saying relative path is not allowed. However, before doing that, it would download the file. So since it downloaded the file, it would write it to the model store location, and then since it's downloaded now, you can just interact with it without needing to provide a path again. So you can see here the fix that they had was pretty simple. They just took the code and this moved it like a few lines up, which solved the issue. But basically, this is kind of what that would have looked like. Allowed URLs at the top. I'm just saying like, okay, only load models in from the temp folder. If I look at the model store folder, there's no malicious models in there. If I make a post request that says temp .. .. .. / / / attacker.mar, the service will respond with an error saying relative path is not allowed. However, if you look at the model store folder, the file has been downloaded. Basically, it just did it in the wrong order. And then, since it's in that folder, you can provide a path without needing to set a full file system path, which lets you load the model and bypass that control. So yeah, I will also talk a bit about some of the other inference servers. So the first one I'll talk about is called Triton. So Triton is a inference server from NVIDIA, so obviously pretty widely used. They're obviously a big player in the space. I've seen Triton in quite a few places. They also recently partnered with VLLM, which is a LLM kind of backend, which is pretty widely used in the space. Again, Triton exposes both HTTP and gRPC APIs, and it exposes them, again, with no authentication and bound to all interfaces by default. They tell you in the documentation that you should only deploy this internally, and you should be very careful about where you deploy it. But again, that's a lot of pressure on whoever's doing that deployment. One of the other things that Triton does is it supports cloud-based repositories. So instead of your models being on disk, they can be in the cloud. cloud, so they can be in an S3 bucket or an Azure storage blob or something, which is potentially dangerous. And they do also expose model management APIs, which in some cases can be abused for code execution. So this is an example of the model management APIs. So Triton has 3 different modes that you can use for model management. The first one is none. If the model management mode is set to none, only the model that is launched at startup will be loaded. And if you want to make any changes, you have to restart the service. So this is the safe one. You know, it's the one by default. It's the one you should use. Poll will continually check the file system or the model repository for new models. And if it sees them, it will try to deploy them. This is fine unless somebody can write to the location where it's loading the models. So for example, let's say if your model repository was in S3, if somebody compromises your cloud credentials and they write a model to that location, they could, in theory, push a model through to the server and then maybe get code execution or deploy a malicious model. The third one is explicit. If this is enabled, it exposes an API at v2 repository models load, and this can just be abused for code execution. So you can see here in the screenshot on the right, the model control mode I have is explicit. I have 3 different, you launch it, and it launches 3 different services with 0000, some ports. Again, there's no auth on any of these APIs. And you can see the output of cat.c password when it's loading my model called load model 1. This is loaded via the explicit API. So how does that work? This one's a bit complicated, but basically this is the API that is used for this call. There's a lot of stuff going on here. The key things you need to do is backend has to be set to Python. If backend is set to Python in this request, Triton will try to run the command python model.py inside of this deployed folder. So of course then you think, well, you have to be able to push a model.py file. And conveniently, this API lets you write arbitrary files to disk. So at the bottom here, what I'm saying is that this basically saying that write a file to disk called model.py with the following contents, base64 decoded. And so with a combination of these 2 things, you're basically writing a file to disk called model.py with anything you want in it, and then you're telling it to run this model file when it launches, which lets you get code execution if you can call this API. The only thing is that the Python file has to contain a class named Triton Python model. It doesn't have to include anything. It can be a blank class, but it just has to be there. Otherwise, you get an error. So this, like again, this isn't necessarily a vulnerability. This is kind of just the purpose of this API call. It's to deploy a model. But if you do see this exposed and somebody malicious can call this, they can, of course, push code, get code execution. The last model type or model serving thing I'll talk about is called TensorFlow serving. This is from Google. This is still getting active updates. I'm not sure how popular TensorFlow is these days, but it's still getting active development. Again, same type of thing, launches interfaces RESTful and gRPC, no authentication by default. Again, they tell you it's your responsibility, make sure you limit access, whatever. This one has less of an attack surface because it doesn't necessarily use Python or PyTorch models. It uses a different model format. However, there is one gRPC call that is only in the gRPC interface, not in the RESTful interface, called TensorFlow serving model service handle reload config request. What this does is it instructs the service to look at a location on disk and attempt to load a model from that location. So if you can write to disk, you can force it to load a new model. Even if you can't write to disk, you can give it some garbage configuration and it will overwrite the running configuration and at the very least just cause the hosting server to stop and crash. So that looks like something like this. This is using a tool called gRPC curl. It's just a way to make gRPC requests. And I'm sending in this handle reload config request. The important thing here is this base path parameter. This will tell the server to look on disk in this location for a file, or a model file, and then attempt to load it. So if you send this, again, there's no auth on these APIs. You send this and you get, it'll attempt to load the model. And yeah, so that's pretty bad. I think that is pretty much it. So just to get an inclusion, obviously there's a lot of kind of stuff I went over. What should you do with this information? So as an attacker, I would say if you're in an environment that's using models in any way, look for places where models are loaded specifically and when they're managed. If you're able to control that or send or load your own models, there's a pretty good chance you can get code execution or do something malicious. Being able to write to location where where models are, if you can overwrite a model that gets loaded in by another service, it's pretty bad. If you're looking at PyTorch specifically, if you're doing any sort of code review and you see torch.load, in a lot of ways that's the same as seeing an eval statement, so you can abuse that pretty broadly. As a defender, you should use safe model formats like safe tensors whenever you can. You need to be very aware of the network exposure of any service that is hosting or serving or has access to a model. A lot of these services have authentication options that are not enabled by default. So if you do see them and you have the ability to enable authentication and authorization, you should do that. And you should also specifically disable features that you're not using. Like if you don't need to load a model in via an API call, that's not something that you should have accessible at all. You should also be conscious of who can write to disk in places where there are models, because if they can write to a location that a model can be loaded from, they can potentially get code execution or privilege escalation in that context. And kind of the last thing is just reading the API documentation. A lot of the stuff might seem a little bit crazy, but it's just written out in the documentation that these are how this type of software and stuff is supposed to be used. And so if you read the docs, you read what the API calls do, and then you kind of just do them, you can get pretty interesting results. And yeah, I think that's it for me. Any questions or anything from anyone? Thank you. Yeah.
Have you seen any companies that are vulnerable to this, or like has there been exposure, or are there any stats for this? Or?
I don't think there's any public stats for any kind of stuff like this. Usually, companies that use this type of software, it's pretty deep in their environment. So like in the cases that I've talked to clients and stuff that use this type of software, it's like embedded in at like a pretty deep level, and then maybe they expose some APIs somewhere. But it's not the kind of thing that they would necessarily expose on the internet or something like that. Oh, yeah, sorry. So if you're just running it like locally, what I would suggest is if you go to Hugging Face, you can search for like a model that interests you, like if it's an LLM. And on Hugging Face, there's like if you just click on deploy this model, there's like a button. It'll give you like 3 lines of Python, which you can just run, and it'll load the model in. And that's all like happening on your own computer or whatever server you want. You can probably even do it without a GPU if the model's small enough. And then once you kind of get familiar with that, like I think like with Inference Servers, that's more of like a corporate thing where you're like, you have like, let's say.
I want to use it like from other computer.
Oh, right, yeah.
From an interface by
Oh, okay, yeah, yeah.
Like I'm a programmer, and I want to kind of use, because the first step is like starting with this, but the end goal would be to have like my own AI.
Yeah.
That I can use by keeping my data private on my stuff.
Yeah.
Use it for API, because all of the rest of this code for itself.
Yeah, so I would say the main limiting factor you have is what model format you're using. Like if it's a PyTorch model, even if it's in the safe tensor model format, like if it's a PyTorch model, then you can use TorchServe to serve it. But if it's like, let's say an ONNX model or another model format, you might be a little bit restricted in terms of what inference server you can use. I think TorchServe is very easy to use. Their docs are pretty straightforward. Triton's was a little bit like confusing, and Google's kind of all over the place. So if you're using a PyTorch model, I would highly suggest TorchServe. If you're using another one, you might be able to find a server that's more directly in line with that model format.
So you will recommend like take PyTorch and a small model, make my teeth on that, and after go after a bigger model that will help me do what I really want to do.
Yeah, and PyTorch is it's by far, I think, the most used of these libraries. So there's a lot of resources for PyTorch, whereas for some of the other ones, you might run into a bit of walls. So yeah, even though PyTorch uses a very dangerous model format, it is also the most heavily used. So there's just the most resources out there for it.
One last question. Do you know anything that can work well with Photoshop?
No. Sorry. Cool. Awesome. Thank you very much, everyone.